In Episode 1, titled How CloudNetX Questions Work, Scenario Clues, Constraints, and Best Answer Logic, we build a repeatable way to decode scenario prompts quickly without getting hypnotized by technical noise. Most candidates do not struggle because they lack knowledge. They struggle because the question is designed to reward disciplined reading under time pressure. The exam tends to offer several answers that are technically plausible in isolation, but only one that best matches the stated outcome and the constraints implied by the scenario. That means your first job is not to remember every cloud feature. It is to understand what the prompt is truly asking you to optimize. Once you adopt a consistent decoding method, the same messy scenario questions start to look predictable, and your confidence goes up because your process is doing the heavy lifting. Before we continue, a quick note. This audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. The first move is to spot the stated goal and to treat it like the North Star that everything else must serve. In many scenario questions, the goal is expressed as a verb phrase, such as improve, reduce, ensure, enable, or migrate, and the noun that follows tells you what success looks like. Then you look for hidden constraints, which are rarely labeled as constraints, but instead show up as ordinary wording about the organization, its users, and its limits. Words like must, cannot, without, only, limited, legacy, and regulatory are not filler. They are the rails the correct answer must run on. If a prompt says a solution must work without downtime, that single phrase will eliminate anything requiring a cutover that interrupts service. If it says without increasing cost, then a high availability design that doubles resources is likely a trap, even if it sounds impressive. Before you evaluate any option, classify the environment, because architecture choices are context dependent, and the exam expects you to anchor your reasoning in that context. When the scenario implies a cloud environment, you should assume elasticity, managed services, and shared responsibility boundaries are in play, even if the prompt does not spell them out. When the scenario describes a campus setting, you should picture a controlled network perimeter, consistent user populations, and stable connectivity, which changes how you think about identity, segmentation, and monitoring. When it is hybrid, you should immediately anticipate integration points, data flows across boundaries, and the operational friction of spanning two worlds. When it is remote-focused, you should assume variable connectivity, endpoint diversity, and a heavier reliance on identity and device posture than on traditional network location. This classification step prevents you from choosing answers that are technically correct but mismatched to the operational reality implied by the prompt. After you know the environment, identify what must not break, because the exam loves trade-offs and wants to see that you recognize which trade-off is not allowed. Uptime might be the sacred value if the scenario describes always-on customer transactions or service-level objectives, even if service-level agreement is not explicitly written. Security might be the immovable requirement when the prompt includes compliance, regulated data, or prior breaches, because those hints raise the cost of risk. Cost can be the immovable requirement when the prompt emphasizes budget limits, cost overruns, or leadership pressure to reduce spend, which means gold-plated solutions are out. Latency can be the immovable requirement when the prompt mentions real-time control systems, voice, interactive user experience, or specific geographic constraints. Your job is to decide which of these is the primary must not break, because that becomes a hard gate for every answer choice you evaluate. Once you have the constraints, translate each one into a design preference you can test against the options like a checklist in your head. If uptime is the immovable requirement, your design preference might be fault tolerance, multi-zone resilience, or graceful degradation rather than a single point of failure. If security is the immovable requirement, your design preference might be least privilege, strong identity controls, segmentation, encryption, and auditable change. If cost is the immovable requirement, your preference might be managed services that reduce operational overhead, right-sizing, pay-as-you-go efficiency, and avoiding duplicate infrastructure. If latency is the immovable requirement, you might prefer local processing, edge placement, direct connectivity, and minimizing hops through unnecessary inspection points. This translation matters because constraints are written in human language, but answer choices are written in technology language, and your job is to bridge those cleanly and consistently. As you start reading the answer choices, listen for distractors that sound technical but do not serve the actual goal, because scenario questions are often designed as a test of relevance rather than a test of trivia. A distractor might mention a sophisticated control, a new protocol, or an advanced architecture pattern, and it may even be something you have heard praised in the industry. The problem is that it can be irrelevant to the stated outcome, or it can violate a constraint that the prompt quietly established. For example, a solution that adds multiple layers of inspection may sound more secure, but if the immovable requirement is latency for interactive workloads, it is likely wrong. A solution that introduces a new platform might sound modern, but if the scenario emphasizes limited staff expertise, it is likely wrong due to operational risk. The exam rewards you for noticing when the shiny technical object is not aligned with the story the prompt is telling. To keep yourself disciplined, apply a 3-step answer filter that prioritizes fit, risk, and simplicity in that order. Fit means the option directly achieves the stated goal within the classified environment without requiring you to make heroic assumptions. Risk means the option does not introduce unacceptable failure modes, security exposure, or operational uncertainty relative to the constraints you identified. Simplicity means that among options that fit and manage risk, you prefer the one that accomplishes the job with fewer dependencies, fewer moving parts, and fewer things that can drift over time. This order matters because candidates often start by admiring complexity, and complexity can feel like competence, but in scenario logic, it often creates unnecessary risk. When you use this filter consistently, you stop arguing with yourself and start making clean decisions based on what the prompt can support. Elimination by contradiction is the next skill, and it is one of the fastest ways to reduce cognitive load under time pressure. You are not trying to prove the correct answer immediately. You are trying to remove answers that cannot be correct because they violate a constraint you already extracted. If the prompt implies no downtime, eliminate any choice that requires a migration cutover with service interruption, even if it promises long-term benefits. If the prompt implies minimal cost increase, eliminate any choice that obviously adds redundant systems, premium tiers, or ongoing licensing overhead. If the prompt implies strict security requirements, eliminate any choice that expands trust boundaries without compensating controls or that relies on shared secrets and broad access. The key is to treat contradictions as disqualifiers because scenario questions are written so that wrong answers often contradict the prompt in at least one clear way. As you narrow the field, build a quick mental model of traffic direction and control points because many CloudNet scenarios hinge on where flows start, where they go, and where you can reasonably enforce control. Traffic direction is about source and destination, such as user to application, application to database, or on-premises to cloud, and the direction often determines which control plane is relevant. Control points are the places you can apply authentication, authorization, inspection, logging, and segmentation without breaking the system's intent. In a remote-heavy context, identity becomes a primary control point because network location is unreliable and endpoints may be unmanaged. In a hybrid context, the boundary between environments becomes a critical control point because it is where trust is most likely to be incorrectly assumed. When you can picture the flow and the control points, you can quickly reject options that place controls where they cannot realistically work. Next, evaluate whether each remaining option scales, survives failure, and limits trust, because these are common quality attributes the exam expects you to consider even when they are not explicitly named. Scale is about whether the design can handle growth in users, traffic, and workload without constant redesign or manual intervention. Survival under failure is about what happens when a component goes down, a link flaps, a region degrades, or a service hits a limit, and whether the outcome violates the must-not-break priority you identified earlier. Limiting trust is about reducing implicit trust relationships and minimizing blast radius so that one compromised identity, one misconfiguration, or one exposed endpoint does not become a total environment compromise. When an option scales but fails catastrophically on a single dependency, it is often a trap. When an option survives failure but requires broad trust to function, it is often a security trap. The best answer usually strikes the balance that the scenario can justify. When two options appear to fit, choose the one with fewer moving parts, because complexity is not neutral, and the exam often treats operational simplicity as a feature. Fewer moving parts means fewer services to integrate, fewer policies to synchronize, fewer places for logs to fragment, and fewer brittle dependencies that fail in surprising ways. This does not mean choosing the least secure option. It means choosing the option that achieves the required security and reliability outcomes with the least operational overhead. A design that requires multiple custom scripts, manual updates, or fragile chaining between components may technically solve the problem, but it increases the chance of drift and outage. Conversely, a design that uses a managed control plane, centralized identity, and clear segmentation boundaries often reduces both day 2 operations burden and incident response complexity. In scenario logic, if two answers meet the goal, the simpler one tends to be the best answer because it respects real-world constraints. To make this repeatable under exam conditions, create a memory anchor you can replay quickly. Goal, constraints, controls, and final choice. Goal is the outcome you identified from the prompt, stated in plain language, and it acts as your single-sentence definition of success. Constraints are the explicit and implied limits that determine what trade-offs are allowed, and they function as your disqualifiers. Controls are the enforcement points you identified based on traffic direction and environment classification, and they guide which architectures are plausible. Final choice is the option that fits the goal, avoids constraint violations, and achieves the outcome with manageable risk and appropriate simplicity. This anchor works because it compresses a complicated scenario into a small, consistent sequence that your brain can execute even when you are tired or rushed. Over time, you stop feeling like each question is unique because your anchor turns uniqueness into a familiar pattern. A quick mini-review step helps lock this in. Restate the scenario in one sentence, then answer confidently, because confidence is usually a byproduct of clarity rather than bravado. Your one-sentence restatement should include the environment, the goal, and the primary constraint, phrased as if you were briefing a teammate. If you cannot restate it cleanly, that is often a signal you are still being distracted by details and should recheck the goal and constraints in the prompt. Once you can restate it, the answer choices often become obvious because you can ask which option best satisfies that one sentence without contradicting it. This technique also protects you from second-guessing because you can tie your final selection back to a clear interpretation of the prompt. The exam punishes impulsive selection and rewards deliberate matching between story and solution. As a final layer of discipline, pay attention to language that implies priority because best answer logic often hides in small qualifiers that change what the exam is truly measuring. If the prompt emphasizes minimal operational overhead, it is testing your ability to value maintainability, not just feature completeness. If it emphasizes rapid recovery, it is testing your understanding of resilience and recovery time expectations rather than raw uptime. If it emphasizes reducing risk, it is testing your ability to tighten trust boundaries and improve assurance, not just to add tools. Even if the word assurance is not used, the scenario can be asking you to increase confidence through verifiable controls and observable outcomes. These subtle priorities can separate two options that both work in theory, because one better matches what leadership, auditors, or users would actually value in that context. Your decoding method should treat these qualifiers as high signal, not as background flavor. Another practical consideration is that constraints are sometimes layered, meaning the scenario can present an obvious constraint and then quietly add a second one that changes the ranking between the last two options. You might see an obvious constraint like cost control, and then a quieter one like limited staff expertise, which makes the best option the one that is not only cost-aware, but also reduces operational complexity. You might see an obvious constraint like uptime, and then a quieter one like regulatory reporting, which makes the best option the one that maintains uptime while also improving logging integrity and access governance. When you look back at the prompt after narrowing to two options, you are not rereading to find new topics. You are rereading to confirm you did not miss a constraint that should break the tie. This is a subtle but powerful habit because it shifts your attention from the answer choices back to the scenario's truth. In other words, you let the prompt decide, not your preference for a particular technology. In the conclusion of Episode 1, titled How CloudNetX Questions Work, Scenario Clues, Constraints, and Best Answer Logic, the goal is to leave you with a simple filter you can reuse on every scenario prompt. You start by identifying the stated goal, then you extract both explicit and implied constraints from the wording, and you classify the environment so your architecture reasoning matches the context. You treat the must-not-break priority as a hard gate, translate constraints into testable preferences, and eliminate choices that contradict the scenario before you ever argue about which is cooler. You then model traffic direction and control points, check scale, failure survival, and trust limitation, and, if two options remain, you choose the one with fewer moving parts. Apply this filter on 5 prompts during your next listen, and you will notice that the exam's best answer logic becomes less mysterious and much more mechanical in the good way. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.